Hello everyone, this is the Science Chef. In this video, we'll be learning about the Graham's law of diffusion, the sixth and last part of a series on the physical gas laws. Please go nowhere, I'll be right back after this break. If you'd like to watch more of these tutorials, please like this video, subscribe to our channel and turn on your notification bell. If you'd also like to watch our past tutorials on the gas laws, please check the link in the description. Diffusion is a movement of particles of a substance from a region of higher concentration to a region of lower concentration. Thomas Graham showed a relationship between the rate of diffusion of a gas and its vapor density or relative molecular mass. According to him, the rate of diffusion R of a given volume of gas is inversely proportional to the square root of its vapor density ρ at constant temperature and pressure, mathematically represented as R inversely proportional to the square root of ρ. But the vapor density of a gas is directly proportional to its relative molecular mass and is given as vapor density equals to relative molecular mass divided by 2. Hence, the Graham's law of diffusion can also be stated thus: the rate of diffusion R of a given volume of gas is inversely proportional to the square root of its relative molecular mass m at constant temperature and pressure, and represented mathematically as R inversely proportional to the square root of m. This implies that the higher the molecular mass of a gas, the slower its rate of diffusion, and vice versa. Also, the rate of diffusion of a gas is calculated as the volume of the gas divided by the time taken for the gas to diffuse. Therefore, for the same volume of gases with different molecular masses, the rate of diffusion will be inversely proportional to the time of diffusion. This is because the larger the molecular mass of the gas, the slower its rate of diffusion, and the longer the time it will take to diffuse. So, for two gases A and B with rates of diffusion Ra and Rb, and relative molecular masses Ma and Mb respectively, then Ra over Rb equals to square root of Mb over Ma. Similarly, if the same volume of the gases takes times Ta and Tb to diffuse, then we can say that Ra over Rb equals to Tb over Ta. A combination of equations 1 and 2 gives the law in terms of rates of diffusion, relative molecular mass, and the time of diffusion. You can always use any two relationships out of these three to solve problems on Graham's law. Let's illustrate the Graham's law of diffusion using ammonia and hydrogen chloride gases. When a glass tube was fitted at both ends with 2 parts of cotton wool saturated with concentrated ammonia and concentrated hydrochloric acid respectively, the vapors of the gases were expected to diffuse from the different ends of the tube towards the center. However, it was observed that dense white fumes formed at a point closer to the end that had the cotton wool soaked with concentrated hydrochloric acid. The explanation behind this observation is that the ammonia gas has a lower relative molecular mass than the hydrogen chloride gas, and as such, it diffuses faster than the hydrogen chloride, and the two gas vapors react to form ammonium chloride, which is seen as the dense white fumes. Now let's solve some problems based on the Graham's law of diffusion. Question 1. 400 cm3 of a gas M diffused through a porous pot in 2 minutes. Calculate the rate at which M diffuses. This is a simple and direct question that requires us to calculate the rate of diffusion of a gas using volume and time. So from the information provided, the volume of gas M, Vm, is 400 cm3, while the time of diffusion of gas M, Tm, is 2 minutes, which equals 120 seconds. Applying the formula, rate equals the volume of gas divided by time of diffusion, substituting the given values and evaluating the equation, we obtain 3.33 cm3 per second as the rate of diffusion of gas M. Question 2. If a gas A is 9 times as heavy as hydrogen, which gas will diffuse faster and by what factor? In this question, we are expected to determine the ratio of the rate of diffusion of hydrogen and gas A using their masses. Therefore, from the given parameters, if the mass of hydrogen is mH, then the mass of gas A will be 9 mH. Let the rate of diffusion of hydrogen and gas A be RH and RA respectively. So applying the Graham's law of diffusion, RH over RA equals to square root of MA over MH. Substituting the values of MA and MH, we obtain 3:1 as the ratio of rate of diffusion of hydrogen to gas A. This implies that hydrogen will diffuse 3 times faster than gas A because it is less dense than gas A. Question 3. Under the same conditions of temperature and pressure, hydrogen diffuses 4 times as fast as gas Z. Calculate the relative molecular mass of Z. Take the relative atomic mass of hydrogen to be 1. Here we are expected to calculate the relative molecular mass of the gas using the relative molecular mass of hydrogen and the rate of diffusion of the gas and hydrogen. So let the rate of diffusion of gas Z, Rz, be x, and the rate of diffusion of hydrogen, Rh, be 4x. Let the relative molecular mass of hydrogen and Z be 2 and mz respectively. From the Graham's law of diffusion, Rh over Rz equals to square root of mz over mh. Substituting the values and evaluating the equation, we obtain 32 as the relative molecular mass of Z. Question 4. If 140 cm3 of hydrogen diffuses in 20 seconds, how long will it take for 245 cm3 of a gas X, whose vapor density is 25, to diffuse under the same condition? Relative molecular mass of hydrogen is 2. In this question, we are to determine the time it will take a certain volume of gas to diffuse when compared with the given volume and time of diffusion of hydrogen gas. The problem can be approached in two ways. First is by solving it in terms of the relationship between the rates of diffusion and relative molecular masses of the gases, and alternatively, we can solve it in terms of the relationship between the relative molecular masses and the time of diffusion of the gases. Let's look at the first scenario. Volumes of hydrogen and gas X are given as 140 cm3 and 245 cm3 respectively. The relative molecular mass of hydrogen is 2, while the vapor density of X is 25. From this, we can calculate the relative molecular mass of X by multiplying its vapor density by 2, and that gives us 50. The time of diffusion of hydrogen is 20 seconds. From these parameters, we can calculate the rate of diffusion of hydrogen using rate equals to volume of gas divided by time of diffusion to be 7 cm3 per second. Then we can calculate the rate of diffusion of X in terms of Tx, which gives us 245 over Tx. After which we apply the Graham's law of diffusion, Rh over Rx equals to square root of mx over mh. Substitute the values and solve for Tx, which is 175 seconds. Alternatively, using the volume and time of diffusion of hydrogen provided, we can calculate the time it will take 245 cm3 of hydrogen to diffuse. This is necessary because we need to subject hydrogen and gas X to the same conditions if our result is to be relied upon. Thereafter, we will use that value to calculate the time of diffusion of gas X. So, if 140 cm3 of hydrogen diffuses in 20 seconds, then 245 cm3 of hydrogen will diffuse in 35 seconds. Applying the alternative form of Graham's law of diffusion, square root of mh over mx equals to th over tx. Substituting the values and solving for Tx, we obtain 175 seconds as the time it will take gas X to diffuse under the same conditions. In our next tutorial, we will be learning about the chemical gas laws, Gay-Lussac's law of combining volumes, and Avogadro's law. As usual, subscribe to our channel and turn on your notification bell to get notified when the video is published, and always stay safe.